Hi, my name is Vasily Bunakov, and in the final video I'll tell you some valuable facts about inner workings of AutoML. In addition, I'm going to answer some questions that users often have. You are already familiar with the general structure of the AutoML pipeline. In this diagram, each element represents a different class in our library. The user can either compose a pipeline from ready-made blocks or write his own blocks and implement them into AutoML. Still, the easiest way is to use the AutoML preset to solve your problem. Let's take a look at some interesting features of the tabular AutoML preset implementation. The preset is a prepared pipeline that adapts a little to the task in the process of work. The tabular preset works with a flat table where one object corresponds to one row, and it is described by categories, numbers, and dates. During training, AutoML builds linear models, tree ensembles, namely LightGBM and CatBoost, and tabular neural networks in that order. A combination of such models gives excellent quality on tabular data. Nevertheless, training and parameter selection can be time-consuming, although training time is often limited. In our example, we have 1 hour. Our goal is to build the best model within this hour using the above algorithms. Before starting training, AutoML distributes the time budget between all algorithms in proportion to the initial estimate embedded into the preset. This estimate is then refined as information about the actual training time becomes available. After one algorithm completes, its unused time is redistributed to the rest. This means that the order in which algorithms work is important to us. Simpler algorithms go first. AutoML can operate in 3 time management modes, and you can switch between them if you want. In mode 0, AutoML does not interrupt training, only limits the optimization of hyperparameters with a lack of time. In mode 1, which is set by default, AutoML interrupts the cross-validation cycle when the time budget of a particular algorithm is exhausted. The new algorithm will not start training if the estimated execution time is greater than the remaining time. The last mode is similar to the previous one, but more strict. The stop will occur a little earlier in order to be guaranteed to meet the deadline. Note that model training results may not be reproducible across systems or due to subtle changes in settings such as the number of CPU cores. And this is due to the training time issue. If such reproducibility is important to you, you can go without time limit and not specify the timeout parameter at all. There is also an inverse problem. Sometimes AutoML completes its task significantly ahead of time. If you had known about it in advance, you could have spent more time training additional models. This is especially important for small tasks at benchmarks or competitions. And to solve this problem, we created tabular utilized preset. Its fundamental difference is that it will utilize all the time allotted to it. Sometimes this can appreciably improve the quality of your model. The next important part of the pipeline is the reader. Contrary to the name, it not only reads the data but also determines how to work with them in the future. Let's remember that fitPredict method of the AutoML class has at least one mandatory argument, which is the dictionary with variable roles. It must contain at least one target key, which value is the name of the variable we predict. However, all variables must have roles in LightAutoML. If the roles are not explicitly specified before starting the training, the reader will attempt to determine them itself, choosing from dates, numbers, and categories. We more or less understand what the date is, but there may be ambiguity between the numbers and categories. Look at the example. In the first case, the histogram of integer variable clearly has an order, and it is distributed as a number. And in the second case, there is no explicit order, and we can suspect these numbers to be categories codes. By default, Reader uses an advanced algorithm for determining roles based on statistics, and it helps to resolve uncertainties of this kind. But the user can always replace it with a simpler one, for example, based on the types of variables. This can help speed up work and prevent overfitting. The basic idea of the advanced typing algorithm is the following. The way we process and encode numerical and categorical variables affects the quality of the final model. The reverse is also true. The role of a variable is determined by the type of processing that makes the model better. The only problem here is that we usually cannot build so much models to evaluate all possible combinations of features and their preprocessing types. Look at the example. In the first case, the histogram of integer variable clearly has an order, and it is distributed as a number. And in the second case, there is no explicit order, and we can suspect these numbers to be categories codes. By default, Reader uses an advanced algorithm for determining roles based on statistics, and it helps to resolve uncertainties of this kind. But the user can always replace it with a simpler one, for example, based on the types of variables. This can help speed up work and prevent overfitting. The basic idea of the advanced typing algorithm is the following. The way we process and encode numerical and categorical variables affects the quality of the final model. The reverse is also true. The role of a variable is determined by the type of processing that makes the model better. The only problem here is that we usually cannot build so much models to evaluate all possible combinations of features and their preprocessing types. Another benefit of advanced typing is that we can immediately recommend the best way to encode a feature already within the assigned role. We can also throw out weak features. This way of defining roles helps us to build the best models on average. However, on some datasets, the algorithm can be overfitted. This can lead to poor quality, especially if the data sample is small. There may also be some peculiarities like what you see on this slide. In one of the open datasets for the credit scoring task, amounts of money are defined as categories for some reason. This looks weird, but in fact it allows you to build a stronger model. This example is not the only one. If you encounter this behavior in real life, this is an important information for better understanding the data. So, we talked about the reader. And the last element of the preset that I would like to highlight today is blending. In our scheme, it stands apart from machine learning algorithms, but in fact, it is a mini model. The main difference is that Blender is always very simple, so we don't need a validation sample to evaluate its quality. For example, in tabular AutoML, the Blender is weighted averaging. For simplicity, we believe that such a model is not overfitted, although in reality, this is of course not always the case. Such an assumption allows us to build a Blender in any case, even when the pipeline has finished its work on timeout and we are not able to do a full stacking. Secondly, blending is able to select models to accelerate inference. If the model has a low weight, it simply will not be calculated during AutoML inference. Another important feature is that with the blending step, can be skipped by setting the return all prediction parameter to true. In this case, instead of one prediction, we will get several predictions of all the final models at once, except for those that did not pass the selection. You can use a whole bunch of predictions for a deeper analysis of the built models. And in the last part of the video, I would like to answer the question that our users often have when they first start using the tool. Usually, when receiving AutoML predictions, users immediately try to use them in their code as an array of numbers, for example by passing a function to evaluate quality on a delayed sample. This action fails with an error, and the reason remains unclear. This happens because the output of the predict method is not a NumPy array, but an internal dataset of AutoML. Besides the prediction itself, this dataset contains metadata that is used inside AutoML. To get an array of predictions from the dataset object, you can use the data attribute and then apply it as usual. Also, users sometimes notice that not a number values appear as a result of fitPredict method. It may seem that AutoML is not correctly predicting some part of the training dataset. The reason is that what appear to be predictions on the training set are actually out-of-fold predictions. That is, the prediction obtained by cross-validation. In case you have a small time budget, for instance 5 seconds, the full cycle of cross-validation has no time to complete according to any algorithm. As a result, the rows for which the prediction has not yet been calculated will remain empty. Note that this cannot happen on a holdout set when calling the predict method. To the next case. If you have already tried multi-class classification problems on AutoML, you could notice that the output of the model is a table with a distribution of classes. And it is not always clear which column belongs to which class. In a given example, you might expect the order of A, B, and C. In fact, the correspondence is arranged as follows. If the class labels are values from 0 to n-1, the index will remain the same. In fact, the correspondence is arranged as follows. If the class labels are values from 0 to n-1, the index will remain the same. In all other cases, the index is determined by the descending order of the class frequencies of the training set. The correspondence may be unintuitive. For example, if the class labels are numbers 1, 2, 3, or letters A, B, C is in our example. You can get the correct class mapping made by reader from the class mapping attribute. And the last question. Users often wonder whether it's possible to pass a group index or object weight to AutoML and how they will be used in the training process. Yes, you can pass the index of a group or the weight of an object using the rows dictionary with the keys of groups and weights respectively. These roles can only be defined by the user. Reader never assigns such roles to variables on his own. Pipelines use groups at the validation stage of the model and generate splits in such a way that objects from the same group never fall into both training and test sets at the same time. The weights will be applied at the training stage, determining the contribution of each individual object to the final model, and by default the weights are considered the same. This is where our video ends. You can get answers to other questions in our Telegram channel and in the chat named Practical Questions about AutoML. Thank you for attention.